All right, we're back. So nice and easy. We're looking at the rules of exponents or exponent laws, but you didn't take geometry yet, so you don't really know what mathematical laws even mean, so we can just call them rules. So at the end, we'll put all these up together if you want to copy them down there. We're just going to go one by one. And don't feel stressed out. This is not as difficult as it looks from our examples here. So first one is product of powers. So if you have two numbers and they have the same base, right? If they're both raised to some power, we can just take those two powers and add them together, okay? So if we look at our examples, d to the 4th times d to the 3rd would be d to the 4 plus 3, or just d to the 7. Okay, nice and simple. So if you just have two numbers being multiplied together, same base, you just add their powers together, there's your answer. Okay, that works if it's not a variable. You can do the same thing. So this would be 7 to the 2 plus 12, or 7 to the 14. Don't actually work that out, just leave it as an exponent, that's fine. Okay. Our second one is the same thing, only instead of multiplying, if we divide, similar idea, instead of adding, we just subtract them. So if we have k to the 9th divided by k to the 3rd, that would just be k to the 9 minus 3, or k to the 6th. It's really nothing to it, right? If you have the same base, if you're dividing, just take those two powers and subtract. No tricks, that's the whole thing, okay? Then we have, because when we do these, we don't really want negative exponents because negative exponents are weird, right? So we could say if you have any power raised to a negative exponent, you can just take it, write it as a fraction, and then flip that fraction over. So take the reciprocal of it. So x to the negative a is equal to a over x to the positive a. And if you start off with a fraction and you have a negative exponent in the denominator, you can flip that. It's a little bit better when you can see the fractions here. So if you have a negative exponent in the denominator, it becomes the positive exponent in the numerator. Okay? Because anytime you write these, you never want to write your answer with a negative exponent. You would rather have a fraction than negative exponent. So z to the negative 6, we would say is just 1 over z to the positive 6. Z, not a 2. Put a little line through it. Okay, 1 over 3 to the negative 16th. So since we have a negative down in the denominator, we're going to flip it over. So bring 3 up to the top. And then negative 16 becomes positive 16. You can put over 1 if you really wanted to, but it's really not necessary. Okay? And this goes for anything. Anytime you're left with a negative exponent, you're always going to want to follow this rule. You're just going to want to rewrite it with a positive exponent. Okay. So next one, power of a power. So if you have some number raised to a power, and then that's in parentheses and it's raised to another power, you're going to take those two exponents and then multiply them together. Okay, so don't add them because you're not multiplying now. Now it's exponent raised to another exponent. So p to the 5th raised to the 6th power would be equivalent to p to the 5 times 6, or p to the 30th power. Come on, there we go. Okay. This rule applies if you have more than one thing, you still have to distribute, which is pretty similar to this. These two go together pretty frequently. So xy to the a power is x to the a. I don't know why this says b. That's a typo. This should say y to the a power. Okay, so they're both raised to that, whatever the power is on the outside. So 3a to the 2nd would be 3 squared times a squared. I don't remember if they wanted you to actually solve this one, but you could rewrite this as 9a squared. I'm not even sure why I'm putting the times there. It would just be 9a squared. But you can leave it as 3 squared as well, because really it's just a matter of writing out what the exponents would be. Okay. Same thing with the quotient. Really, there's nothing different here. It's basically, it's still saying anything raised to a power, if it's in parentheses, then that exponent applies to top and bottom. So x over y raised to the a power is equal to x over a divided by y over a. So this one here, b over h to the third power would be equivalent to b to the third power divided by h to the third power. Okay. This one down here, this is not as useful because this is just it's a rewriting of our, where is it, negative exponent rule. But it basically says if you have an entire fraction raised to a negative power, you can just flip the whole fraction and then change that to the positive version of the exponent. So 2 to the third raised to the negative third power. So I'm just going to flip 2/3. That's going to become 3 halves. And then instead of the negative third, that would be equivalent to the positive third. And then we could expand that out. This would be 3 to the third divided by 2 to the third. Okay. The reason why we say this isn't as useful is that if you skipped over this, like, let me make this smaller. Yep. So let's just say I work this out. So 2 to the negative third, that would be 2 to the negative third divided by 3 to the negative third. And then using our negative exponent rule, I know if I have 2 to the negative third, that's going to be, I'm just going to flip this over. So that was on the top, now it's on the bottom. What's on the bottom, that has a negative exponent, so I'm going to move that to the top, and then that negative 3 becomes positive 3. And we end up with the same answer, okay? So you don't really need to remember this one, as long as you remember this rule here. And you're not going to get far at all if you don't know this rule here, so, I mean, definitely know this one. And then as long as you know that if you have an exponent outside the parentheses that applies to top and bottom, you can get the same answer without having to memorize all of this thing. Okay? And then our last one, last but not least, is any number raised to the 0 power equals 1. Okay? Any number. So x to the 0 power, doesn't matter what x is, as long as it's not 0, that's a whole different thing. That will always equal 1. Okay? So 23 to the 0 power is 1. Anything to the 0 power, 1. Don't think about it. Don't work about it. Don't look at any of these other rules. If you see the 0 power, you just call it 1. You're done. Don't make it harder than it needs to be. Okay, so practice some of these. You just got, I don't know, this is pretty easy. This is only like 10 questions. If I could click this, there it is. So like d to the 3 times d to the 6, well, 3 plus 6 is 9, so that would be d to the 9. So I don't think any of these are that difficult. You should be able to breeze right through that. Let me, because I said I would. Page length, so you can pause it, you can watch it. I'll make a cool face. You can pause right there. Whoa, look at that. Okay. So good luck. If you need help, just let me know.